Right, hello. So this video is looking at the microscope RPA, but it's looking at exam practice. So what the questions might look like and how you could answer them. So we'll go through it. Just to say, it's not really explaining the RPA, it's assuming you know that. So I would check you've watched the Microscopes RPA video first. It's a real laugh a minute, it's exhilarating stuff. Probably win a couple of awards at some point in the future. This video is going to look at how you might change magnification and resolution, how you convert units, and we'll look at some of the maths you need to know. So just to remind you, here's a microscope. If you need to improve magnification, you change what's called the objective lens. You can just flick them around on the microscope. If you need to change your resolution, then you must twiddle around something called the fine focusing wheel or something called the fine focusing dial. You can use whatever term you want. I prefer dial because I can't say the other one properly. Don't judge. So here's an exam question. Look at the slide. How could you adjust it to the microscope, that is, to see it more clearly? So I have a look and I think, is the problem the magnification, that is, it's too big or small, or the resolution, the image quality? Now in this case, the problem is the resolution. That image is big enough, I can see the outline, but it's blurry. So to improve resolution, I'm going to adjust the fine focusing dial. And there's 2 marks there potentially, one for saying it's a resolution problem and one for saying how to improve it. Here's another slide, same question. Again, is it magnification or resolution? Now in this case, the resolution's pretty good. I can make out the details, but they're just too small. So it's a problem of magnification. So in order to improve it, you change the objective lens. So there's my 2 marks again. I say the problem is magnification and I say how you can improve it. I went over this in a lot more detail in the actual video, but a quick reminder, because we're dealing with small things, we use small units. So millimeters is the biggest one, and micrometers is 1,000 times smaller, and nanometers is 1,000 times smaller than a micrometer. So to go between them into a smaller unit, you times the number by 1,000, and to go the other way into a larger unit, you divide it by 1,000. So into a smaller unit, you'll multiply by 1,000. Into a bigger unit, you'll divide it. Like I say, I explained why that is in the other video, but that's a quick overview in case you forgot. So we'll just do a quick example. I've got an ant and it's 65 millimeters, which when you think about it, it's disturbingly big. That's a monstrous ant. But how big is it in micrometers? I'm going into a smaller unit, so I just need to times that by 1,000. So 65 times 1,000 is 65,000 micrometers. So that ant, I could say it's 65 millimeters, or I could say it's 65,000 micrometers. Now we've got a bacteria that's 4 micrometers long, but I want to know its length in millimeters. So it's going into a bigger unit. So now I'm going to divide that number by 1,000. So 4 divided by 1,000 gives me 0.004 millimeters. So I could say it's 4 micrometers, or I could say it's 0.004 millimeters. That's just an example of the conversion. Now, I know you love maths, so you're in luck because we got some for you. You might be given an image of something under a microscope and be told, find the magnification, or find its actual size, or find its image size. And these are linked in this triangle. Now, often you'll be given 2 of the 3 things. So you'll be given 2 and you have to find the missing third. Again, I've been over this triangle, but basically if it's above or below in the triangle, you divide them. And if they're next to each other, you multiply it. And all you do is cover up the one you're looking for. So if I'm looking for image size, which is the eye, I cover it up and I'm left with actual size times magnification. I could get 3 equations from this triangle, and here they are. So again, you should be given 2 of them in the question. Just work out if you times them or multiply them by using that triangle, and then do that. They might try and catch you out by saying, what's the image size? I developed a stutter there. And you might just have to use a ruler and measure it. So, don't forget you've got a ruler and you've got common sense. Now, the trickiest one is this, it's magnification. To find that out, you do the image size divided by the actual size, but they have to be in the same unit. So if the image size is measured in millimeters, but the actual size is in micrometers, you have to put them into the same unit first. I'll show you an example. A student loves cells and they've spent their afternoon drawing this cell here from the microscope. You can see on the diagram it's 112 millimeters long, but the actual cell is 280 micrometers. And the question says, what's the magnification? So step one, you're going to put them in the same unit. Let's say we're going to put 112 millimeters into micrometers. So because it's going into a smaller unit, I times it by 1,000. So I have 112,000 micrometers. So now magnification is the image size, which I now have as 112,000. And I divide it by the real size, which is 280, and that will give me 400. So that little times next to the 400 tells me it's 400 times bigger. In other words, the magnification is 400 times bigger. Now, in that case, I put millimeters into micrometers, but I could have done the other. It doesn't matter what way I put them in, as long as they're put into the same unit. So let's say, for example, that I'm actually going to put 280 micrometers into millimeters. So now, because I'm going from micrometers into millimeters, that's a bigger unit, I divide it by 1,000, and that gives me 0.28. So now the magnification equals 112 millimeters divided by 0.28 millimeters, and that gives me 400. So I think that's the last slide. You should know how to change magnification and resolution, convert some units, and be able to calculate magnification, actual size, and image size.